Olá, você. Hey, Peter.
Hello.
Hi, can you hear me all right?
Yes.
Cool. Okay, so what we working on today? Anything specific? Or I guess first, before we get into that, how are you? Everything good with the power being out, water, all that stuff?
Yes.
Good to hear. Yeah, we had no power and no water brief well at my house in Katy, so I'm in Houston right now, but here everything's good. So yep. Okay. I guess now we'll get started. Do you have anything specific to work on today or not really?
Not really. I'm not,
Okay.
because we haven't been to school for a while, so
Mm-hmm.
not really.
Okay, gotcha. What was the last, do you remember kind of the last topic you worked on so I can figure out where
Uh,
you are?
no, it's been a long heck of a week.
Long heck of a week.
Mhm.
Okay. We'll just do some word problems then to get some
Okay.
practice in if that sounds good.
Okay.
It will be the star though, so prepare yourself.
Okay.
Okay, here, let me get this pulled up. Okay, here, we'll do the 2018. Okay, can you see my screen all right?
Uh-huh. The star.
Yep, you got it.
Mhm.
Okay, so we'll scroll down. See what's up. Ooh, okay, this will be a good little review, some negative numbers. I'm gonna put some little notes here on the side. So for adding and subtracting negatives, we can do leave,
Mhm.
change, opposite, right?
Yes.
Okay, and the rules for multiplication and division are a little bit different. Do you remember those?
The rules for multiplication and division. No.
That's okay.
Sorry, I don't remember anything.
It's been a long week. Okay, so
The only
positive.
thing, the only thing I've been focusing on is are we gonna make it?
Yeah.
Mhm.
Yeah, no worries. So positive times a positive, is that going to be positive or negative?
Positive times a positive would become a negative.
Well, it would say a positive. So think like 5 times 6 is 30, right? That's just a
Uh-huh.
positive number.
Uh-huh.
Okay. What
Yes.
about a positive times a negative?
Mm, positive times a negative. Uh-huh. The positive times a negative equals positive.
Okay, so it's negative. So whenever our signs are
Oh God.
different,
Hmm.
that's when it's negative.
Okay, thank you.
Yeah, and then, okay, one last one. What's a negative times a negative?
A negative times a negative would be a negative.
Okay, are the signs the same or are they different?
The signs are the same.
Okay, and so whenever signs are the same, our answer
Mhm.
is positive. So negative times a negative is positive.
Okay.
You can think about um like in English, if you say
Hmm.
you are not my friend. Well, two negatives makes a positive. So you
Yeah,
are
it
my
both cancels each other out, I
Yeah.
guess.
Yeah, so that's
Uh-huh.
how it works for multiplying and dividing too.
Oh, okay, got it now.
Okay, cool. So let's do this problem right here. So I want you to do the order of operations on this one.
Okay. The order of operations. Hmm. That would be Uh, I mean, first, the first step would be neg uh adding the two negatives, and that would be negative 13, right?
Okay. So whenever, remember, so there's more than one way to write multiplication. So we can use a
Mhm,
multiplication sign like this, we can
mhm.
use a dot, or we can use parentheses. So actually what we need to do first is this one right here, this multiplication fact, because multiplication comes before addition and subtraction.
Oh, because inside the parentheses there's nothing, right?
Uh-huh, yep. There's just two
Okay.
numbers touching.
Okay.
Okay, so what's 5 times negative 6?
5 times negative 6 is sorry.
You're good. Take your time.
How do I
Feel
not?
free to look at the notes.
Okay, 30, right? Negative 30.
Uh-huh, very good. Nice job of remembering the
Uh
negative.
huh.
Okay, so
Okay.
now we have negative 30 plus negative 7.
Uh huh.
So this is where you can do leave change opposite if you want, if it'll make it easier. But you don't have to do leave change
Yeah,
opposite.
that would be pretty easy. That'd just be 37.
Okay, positive or negative?
Negative.
Yep, very good. Okay, so negative 37. And that makes sense, right? Because if you
Yeah.
buy shirts and if you spend money on lunch, you're going to be losing money. So it should be negative.
Yes.
Okay, I'm going to take a quick little screen grab of this real quick, just since we wrote so much stuff on the side. Then I'll put it in a Word document or something maybe. I think that would be easiest.
Okay.
Should have had a Word already open. Sometimes it takes a while to load. Okay, there we go. Let's move down to the next problem.
Okay.
Oh, so this one, um, let's see. You actually have equations or a formula sheet here, so we'll copy down the formula sheet.
Okay.
The area of a trapezoid here. We'll write that down on the side. So area is 1/2 times the bottom base plus the top base times the height.
Wait. So we have star in 6th grade.
Mm-hmm.
I didn't know that.
Yeah. This year they were talking about potentially canceling it, but I think they decided that they're going to keep on doing. I think they, at least before the crazy winter power outage, they decided that they were going to do the star anyways. And if you were
Uh-huh.
online, you were going to come in person to school for like a day or
Mhm.
something and take the test. But I
Uh,
don't know. It might change because they missed out on so much instruction time with the
True.
power.
Yeah.
Can't
I mean,
say
I
for
hope it does. I'm sure every single student wants it to.
Yeah, I'm sure the teachers too, because a lot of the stuff I bet you probably haven't gotten the chance to do
Mhm.
in class.
Mhm.
Okay, I'll stop talking. So
Yeah,
how would you
please.
do
I'm just kidding.
how would you do problem 2?
For problem 2, confusing. Sorry, this is confusing for me. Wait, so A would be the whole thing, right?
Uh-huh. Yeah. And
Okay.
we don't know what A is, so we're just gonna leave it
Mhm.
written as A.
So,
Okay. So we need to figure out what B1 is, what B2 is, and what H is.
I feel like Y is 4, maybe.
Oh, so you don't have to solve for X or Y. It's impossible to solve for X or Y. You don't
Oh.
have You just have to figure out which equation can we use. You see how these still have all
Uh,
the letters inside them, all the
oh,
variables?
so we're only supposed to find the sum for 6 plus 10?
Uh-huh,
Okay,
yeah,
I
so
thought
if
we,
you have,
because it said the whole area, so
yeah,
sorry.
no, because to figure out the area, you have to know what the bases are, and you have to know the height, which we don't know what the
Hmm.
height is. Instead, it
Yeah,
gave us a bunch of variables.
okay. So then it would be A equals 1/2 parentheses 6 plus 10 uh, x.
Uh-huh, X, very good.
Uh,
So answer choice G, right?
G, yeah.
The reason why is we talk about height a lot in
Hmm.
geometry, and we don't really know what it means, but a height is something that forms a right angle.
Okay.
Uh,
Okay.
so let's say that we're doing the area of a triangle.
Hmm.
In this triangle, our height would be this center line right here, because this is the line that forms a right angle. If we
Yes.
did our triangle like this, well, this is the one that forms a right angle, so that's our height. Okay, any questions about this?
No, I think I got it.
Yeah, this
And now,
one, I
yeah, now that I understand the concept, it seems pretty simple.
okay, good, good.
Yeah.
Yeah, and if it told you what X was or if it told you what A is, you could solve for the other
Mhm.
missing pieces, but since it doesn't tell us, you don't have to know.
Okay. Yay! Less work for me.
Yeah, if you had to solve for the missing pieces, that would be algebra, and that is no fun. So,
Yeah, algebra no fun, bad.
okay, so question
Mhm.
3. This one's about integers.
Mhm. So can I start?
Yeah, sure.
Okay. So the first one is correct, and the fourth one is correct. So 1 and 4. So D.
Uh-huh, very good, right? Because
Mhm.
absolute value is always positive.
Yeah. It can't be negative.
Good,
Hey, you're helping me. You're helping me get my memory back.
good, good. Okay, so do you remember how we show absolute value in math? Like what symbols we use?
To show absolute value in math, we uh oh, it's like on the tip of my, what is it? I
You want
don't
a
know.
hint?
No, yes, please, yes, please.
You put these little straight lines around it. So
Oh,
if it
right.
has a straight line on either side, that
Uh-huh.
means that this is the absolute value of
Wait,
negative
why'd
4.
you make it negative then?
Oh, because this says we're taking the absolute value of negative 4. The absolute value of negative
Oh,
4
okay.
is 4.
So I thought you meant like we put the straight lines on the absolute value, but we're putting the straight lines on the number that's being changed to the absolute value, right?
Uh-huh, yep. Just like how we use a multiplication sign to show that we're
So
multiplying something.
basically, sorry.
Oh, you're good. Say what you're going to
So
say.
so basically, you mean if a number has those lines, it means to treat it as an absolute value instead of the number, right?
Uh-huh, yep, exactly.
Okay.
I can't remember if there's. Oh, sometimes I was going to tell you, you might use a calculator sometimes for math instead of by hand. A
Hmm.
lot of time on a calculator, they'll have something like this. It's abs, and then you just put in your number like that and press
Hmm.
enter, and then it'll return the absolute value. So it's a little bit different on a
Oh,
calculator.
okay. Yeah, because question though,
Hmm.
calculators. Just out of curiosity, it's not like I'm gonna cheat on a test or anything. Just curiosity. Calculators can't do like algebra, right?
So some can actually, depending
Really?
on what type you have.
Because
Yeah.
I've been thinking algebra is like you can't really understand it if you know what I mean. So like a computer, well, like does algebra have logic in it?
Yes. So you
Okay.
can actually a calculator is basically a code that solves problems.
Uh-huh.
And so I have actually this like coding software on my computer called MATLAB, and you can write code to solve algebra
Ooh,
problems and other problems. Yeah.
fancy.
Yeah, I have to do it for my homework. It's
Oh,
not
okay.
fun.
I
Yeah,
mean, you do get an advantage because you get to use the calculator.
that's very true.
Anyways, back on topic.
Okay, question 4. We're looking
Uh,
at some dot
yeah.
plots here.
Okay, the dot plot shows the length of the 12 trailers sold at a store last month. Which statement about the data is true? The interquartile in
Interquartile.
yeah, interquartile. Oh my god.
You got it. Interquartile.
This 4 day no Wi-Fi had made me go barbarian. The interquartile range is 7 and the range is 17. So, mm, so F is wrong because the range isn't 17. It just ends at 17, but it begins at 6, meaning the range isn't 17. And the interquartile range is 7. Wait, I forgot what interquartile means.
Okay,
Sorry.
you're
Okay.
good. So usually when we talk about quartiles, we don't
Mhm.
look at
Oh, right. Sorry.
we
Interquartile is the center, right? Center of the graph.
kind of. So have you seen a box and whisker plot before?
Mm-hmm. Wait, no. Sorry.
Oh,
Oh,
okay.
these.
So
Yeah. Yes.
yeah, so usually when they talk about interquartile ranges, they're
Mm-hmm.
talking um about a box and whisker plot. And so it's actually based on the median. And so what I would do to figure out the interquartile range is first we have to figure out what the median is, right?
Mm-hmm.
Okay. So I'm just going to copy down all our data like this. You don't have to do it like this. You could cross out dots if you want it. I think this is just easier to see.
Okay.
Um, okay. So we have all our data copied down. So now we need to find what is the middle of this data.
Uh-huh. So like the
So,
middle number, right?
mhm. So that means that there's going to be 6 numbers on each side, right? Because we have
Uh-huh.
12 data points.
Yes.
Yeah. Okay. So what is in the middle of 9 and 13?
The middle of 9 and 13 is middle of 9 and 13. It is like 11, right?
Uh-huh. It's
Oh, wait,
11.
no, 12.5, right? Wait, no, 11,
It's
11.
it's
Oh,
11 because 9 plus 13 is 22 divided by 2
uh-huh.
is 11.
Yeah.
So this is the
Mm-hmm.
median. Let's
Mm-hmm.
flip back to our plot real quick. So interquartile range, what we do is we find basically we split our data into 4 pieces and then
Uh-huh.
we figure out how much space is in between those pieces.
Yes.
So here, let's split our data into 4 pieces. So, oh, trying to draw here. So here's piece 1, here's piece 2, piece 3, piece 4. So interquartile range, we look from here to here. This is the IQR. Okay. So what is our interquartile range?
The interquartile range is, since it's the center, the interquartile range. Okay, so G would be wrong, right?
So G is actually right because look, it
Uh,
goes from 13 to 6. What's 13 minus 6?
13. Oh, yeah, sorry. 13 minus 6 equals. Yeah, sorry. 13 minus 6 equals 7, right?
Uh-huh. Yeah.
Mhm.
And
Okay.
so G is the answer for this one. I don't know where they got 2.75 from. I guess I don't know. Usually they give answers that are kind of close to something, but it looks like they didn't. Hmm, I don't know.
Hmm. Interesting.
Yeah, but this is how we do it. And if
Okay.
you didn't want to rewrite all the numbers, you could cross out dots, one from the maximum side,
Uh-huh.
one from the minimum side until you got to the middle. I just like to put them in a line because I think it's easier to read.
So, just to be clear here,
Mhm.
the number of the dots doesn't have anything to affect with the interquartile range, right?
So the number of dots tells us how many times that number happens. So you see how 6
Uh-huh.
has 4 dots? So
Uh-huh.
we wrote down 6 1, 2, 3, 4 times.
Okay.
And then 9 has 2 dots, so we wrote down 9 1, 2 times.
Oh, okay. Now I got it. So the numbers that have no dots in them don't count, right? As part of
Yes.
it, right?
Uh-huh, because they
So
never
basically,
sold that many
uh-huh.
trailers. Mhm.
So basically, you get all the numbers, you line them up by how much there is, and then you cross out until you find the middle, right?
Uh-huh. Yep, very
Got
good. And
it.
then you split into 4 pieces
Uh-huh.
to
And
find,
that's the yeah,
yeah, because
quartiles.
quartile is like quarter, you're splitting it
Uh-huh.
into fourths. Mhm.
Uh-huh.
Yeah. The reason why they do this, and you might learn this later on in class, I don't know, but this data here that's in the interquartile range from 6 to 13, this represents 50% of your data. And so here is
Uh-huh.
25% of your data, and here's the other
Whoa.
25%. And so it all adds up to 100%, right? So all your data is
Yes.
shown in this little um, collection of quartiles.
Hmm.
Okay, let me take a
Okay.
screenshot of this, and I'll put a picture of a box and whisker plot too in the Word document just because I think that is important to know. Yeah, we made kind of a ugly looking homemade
Don't say that.
plot. Okay, drawing is not my strong suit.
Hmm.
Not everyone can be an artist.
That is true. Well, it depends on their motivation.
That's maybe they work hard enough.
Yeah,
We'll
maybe.
put it this way, I could never be a math artist. Okay,
I don't think any child would think of math as an art.
very true. Okay. So I'll leave you to just however you want to solve question 5. You can talk
Mhm,
to yourself like through your thought process, or you can just do it in your head.
mhm. Okay. Wait, question. I'm already confused.
Mhm.
So it says a carpenter charges $720 for 18 hours of work. She charges the same amount of money for each hour of work. Does that mean she charges $720 for 18 hours and $720 for 1 hour?
No. So that means um
Uh,
do you remember when we talked about additive and multiplicative relationships?
no.
No, that's okay. It was a
I
long
forgot
time ago.
everything.
Okay, so
Mhm,
an additive relationship is just like it sounds. We're adding. So maybe
mhm,
something like y equals x plus 2. So for each
yes.
number, we just add 2 to it.
Mhm,
For multiplicative, we are multiplying. So maybe y
yes.
equals 3x. So on a graph, this one might look something like this. This one might look something like this. So the difference is basically where is the intercept? Is it at the origin or is it at somewhere else? So if she charges the same amount of money for each hour, that means that she charges like some amount of money per hour, maybe like $10 per hour, $12 per hour,
Mhm.
$14 per hour. We don't really know yet. You'd have to do the math to figure out. What this is telling us is that our relationship is multiplicative if she charges the same amount for each hour of work. It's multiplicative. So 0 hours of work would cost $0.
Yay! Well, okay. So now I get it. So basically, we're dividing for, because that's just an example, right? But if we bring it down to 1 hour, then we're dividing 720 by 18, right?
Exactly.
Okay. I need paper. What? Oh, okay, sorry. Uh, I need to get paper.
You're good.
Oh God, and I don't have a pencil. There it is. Okay, so 720 divided by 8.
Oh, divided by 18.
Oh, right, yeah, 18. Got it. Excuse me. I think I'm suffering from forgetting how to do math. I'm suffering.
You want me to get you started?
No, like now I remember what to do, but I putting the multiply. Mm,
That's okay. You got this, Peter. You can do it.
okay, got it. Mm. Yeah, I need help. So basically what I did is I divided 18 by 720.
You're
Uh,
dividing 720 by 18.
oh wait, no, sorry. Yeah, sorry. That. Yeah, I did that. And I subtracted 64 from 640 from 720, and I added that, put that up, and then I got 71, and then I subtracted
Oh,
by
where
64. Yeah.
where did you get 640 from?
Cause how do I explain this? Let me just show you what I did.
Okay, sure.
Sorry.
You're good.
Oh, oh, never mind. Can you give me an annotation perms, please?
Sorry, what did you say?
Can you give me annotation perms, please?
Oh, yeah, sure. Here, let me turn that on. Okay, you should be able to annotate now.
Okay, thank you. So the first thing I did is I did this like that.
Okay, good setup.
And then uh, I was able to put in 18 four
Okay,
times. So
so
I,
you
uh,
didn't line your number up in the quite right spot. So
uh,
18 does not go into 7. It does go into 72
mhm.
4 times. 18 times 4. Let's do that math out. 8 times 4 is 32. Carry the 3. 1 times 4 is 4 plus 3 is 7. So 72.
uh, I
Yeah, so
guess,
I think
yeah.
I think you made a multiplication mistake maybe.
I thought it was supposed to go on for a long time. So I guess then the answer would be 4, right? Yeah.
40. Yeah,
4.
cuz we
Oh,
got to
right,
make
yeah, 4.
cuz it's
Because
720.
mhm.
Okay, so now we know that she charges $40 per hour. So we just need to find a table that shows work that costs $40 per hour.
So yeah, so now we need to find the correct set. So C would be wrong, right?
Uh-huh. Yeah, there she's charging 25 per hour, right? So it'd be times 25 times 25 like that.
Mhm. D would be wrong too.
Yep, right, because
Uh-huh.
that's not additive or multiplicative. If we were
Yeah.
to graph that, it would just look like this. This would be 720.
Hmm. Okay, so B would be wrong too. So A would be correct.
Yep, exactly. A would be correct. Yeah, a good way to eliminate B is look, it says that 18
Hmm.
hours is $720.
Hmm.
Automatically, we know this one's wrong because it says 19 goes with 720, not 18.
Hmm.
Okay, any questions about this?
No.
Okay, is the additive and multiplicative coming back to you a little?
A bit, yeah, a bit.
Okay. I think that might have been the last thing we did. I remember we talked about it a little bit, but I can't remember when that was. Okay, 6. Oh, so I remember doing this, some percentages.
No. An engine is operating at 25% of its full power. Which number line shows a plot that represents 25%? So this one should be easy, right? We just have to count the total amount in each number line and then see, like, divide by half and divide by half again.
Mhm.
Okay, so F is wrong because that it's just 2, not 2.5.
2, 3, 4, 5, 6, 7, 8, 9, 10. So this is split into tenths. This
Hmm.
is sitting here at 2 tenths. Sorry, just get
Hmm.
some active practice. What
So
would 2 tenths
basically, oh,
be as a
sorry.
percentage?
So basically, the number has to be odd. No, like it has to be like something around 12 or something.
Or it could be split into 4 pieces. It could be split into 8. It could be split into 12. Oh, it got messed up. The reason why is because 25% as a fraction, 25 over 100, that is 1 over 4. So it could also be 2 over 8 or
Oh,
3 over 12 or
mhm.
something like that.
Yeah, I found the number. It's 12. It's J. I told you it was something around 12.
Okay. 1, 2,
Yay.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's at there's 12, but this is 1
Mhm.
12th, 2 12th, 3 12ths, 4 12ths. Is 4 12ths 25%? Not quite. This is actually 33.3 repeating percent. So we want it
Uh,
because you got to look at not only how many pieces is it split into, but
mhm.
where is our dot?
Uh, okay. Then I'm guessing it's H, right? Well, not
Okay.
guessing, because
Okay, so let's do it together. So what is our denominator for this number line?
our denominator for this number line is. I forgot what denominator is.
Okay, the
Oh my god.
bottom part
Oh
of the
wait, no, sorry.
fraction.
Denominator is 5. Denominator is 5.
Okay, and where is our dot at?
Our dot is at our dot is at the second one.
Okay, good. So 2/5.
Hmm.
What is 2/5 as a percentage?
2/5 as a percentage is 2/5. Sorry, 2/5 as a percentage is no, it's 40%. Sorry.
So is that 25?
Sadly, no.
Nope. And so which answer choice is left?
The only answer choice that's left is G.
Yep. So G is our answer. And let's look at Y. So we have 1, 2, 3, 4, 5, 6, 7, 8 as our denominator. Our dot is at the second one, so that's 2 eighths. 2 eighths is the same as 1/4, which is 25%. So whenever we do numbers lines like this, we have to think, okay, first, how many pieces is our number line split into? And then where is our dot? Because that'll tell us first the denominator and then the numerator.
Okay.
Any questions about this one? I know it can be a little tricky.
Yeah, it was, but I think I got it now.
Okay.
Yeah.
Yeah, it's probably been a long time since you've looked at changing percentages to fractions.
Yeah, it is. It has been a while. Yeah.
Oh, okay. So this one you have to do a conversion.
Mhm.
I'll copy down what would be on your conversion chart. So it would tell you that uh 1 pint has 2 cups, and then 1 cup has 8 ounces.
Can I? Okay.
You might want to do this one on a sheet of paper, maybe.
Yeah. So it would be 1.5 or
Uh-huh.
1.5. Yeah.
Yep, very good. I'm going to show you something. If you don't like it, you don't have to look at it, but they will teach you this later on in school to do like science
Okay.
problems and stuff.
Okay.
So we have 24 ounces. And so what we do
Mhm.
is we make a train track, and our goal is to get our units to line up diagonally. So we know that
Mhm.
there are 8 ounces in 1 cup. We want our units to line up again. We
Mhm.
know that there are 2 cups in 1 pint. And so everything on the top we multiply. So let me change to a different color. Everything on the top we multiply,
Mhm.
and then we divide by the stuff that's on the bottom. So that's 24 divided by 16, which is 1 1/2. So this is a way that they'll probably teach you to do these type of problems later on in school. So if you see that, that's what
Mhm.
they're doing.
Okay.
Yeah, and this will work for doing any type of unit changes. So it can be pretty useful if you like it. Not everyone likes it though.
I think I'll just. I don't like it. Me no likey.
That's okay. If
Okay.
you ever see anyone do it though, now you
Mhm.
know what it is.
Yes. And thus another skill I have obtained.
Hmm. Yeah, I don't know. Like, you know how sometimes your parents will do math problems differently than you do?
Yeah, it's because they were born in a different generation.
Yeah, so maybe if you ever ask, I don't know, your mom or your dad for help with homework, they
Mhm.
might do it that way
Yeah, and they
instead of,
don't know good learning.
don't tell them that.
Mhm.
Okay, 8 is a little tricky. I don't think you've learned this yet. So let me, or a little bit. Distributive property. I think we
Distributive
talked,
property. Yeah.
yeah, do you remember when we
Uh-huh.
talked about the associative, commutative, and distributive properties? Oh, this is a long time ago.
Mhm.
This is using
Yes.
these properties.
Yes. Hmm. I remember.
Do you want a quick little definition or example of each of these?
Yeah, just a quick little definition.
Okay. So associative is all about parentheses, and we can do it for addition and multiplication.
Okay.
So if we have 2 plus 3 plus 5, we can put parentheses here, or we can
Hmm.
put our parentheses here, and it doesn't change the answer. These two are equal to each other. For
Hmm.
commutative, that says that we can change the order that we add or multiply things in. So 3 times 2 times 1 is the same as 1 times 2 times 3. Distributive is the one that is a little bit different. So let's say we have 3 times 2 plus 5. What's that saying is we can do 3 times 2 plus 3 times 5. And you can picture it like these little arrows going inside the parentheses. So that's what
Okay.
each of these properties is.
Okay.
This one is specifically what property is it using? Is it using associative, commutative, or distributive?
That one is using associative.
Okay, not quite. So this is actually using
Wait, no. It's I mean, obviously it's commutative, but like
for outside the
yeah.
parentheses, it's distributive. And I'll erase this so it looks a little easier to read.
Okay. So I think F would be wrong.
Okay, good.
Mhm.
Has
And yeah, sorry.
I was going to say it has no multiplication in it, right? Which we know
Yeah.
distributive, we need to have multiplication.
Mhm. So I like it. The answer is G, right? But I'm gonna read over the other
Oh,
questions.
so the answer is actually J, like
Huh?
jellyfish or jump.
Oh, really? Because
Yeah.
here's my thought. So you know how y plus 2 is in parentheses?
hmm
If we do that, oh, now I realize my mistake. Okay, because you're adding it before you multiply it, right?
So what we do is we multiply
Mm-hmm.
5 times the first thing in the parentheses,
Mm-hmm.
and then we do an addition sign, and then we do 5 times the second thing in the parentheses. So it's 5 times y plus 5 times 2. And then this plus 4 is not part of the anything in the parentheses, and so it just sticks
Mm-hmm.
by itself at the end. We don't do anything to it.
Okay.
Yeah.
Okay.
But we basically we still keep this plus sign that's in the middle. We just do our 5 times y, keep our plus sign 5 times 2.
Okay.
You want to do some more practice with this?
Yes,
I'll give
please.
I'll give you some real numbers, not this
Okay.
variables, just to get some practice.
Okay.
Okay, so you can solve this without distributive property, but just to get some practice, see if you can solve it with the distributive property.
Okay. So without the distributive property, that would be so without the distributive property, mm,
We do our PIMDOS or GIMDOS, right?
yeah. So if we remove the parentheses, then oh, I got an idea. I don't. Maybe this probably won't work, but what if uh what if 3 times 4 plus 3 times 2?
That is right. That is how you do the
Oh, okay,
distributive
okay.
property. Yeah.
Uh-huh.
So
Got it.
3 times, so you got it exactly. So 3 times 4
Uh-huh.
plus 3 times 2. That is the definition of the distributive property. If we were
Mhm.
to do it without, we would do GIMDOS. So first we do our grouping. So 4 plus 2 is
Uh-huh.
6. 3 times 6 is 18.
Uh-huh.
No matter what, we get the same answer if we use the distributive property or if we don't. Um,
Mhm.
but yeah, so you got it. You figured out how to do distributive property. You want to try an example with a variable in it?
Yes.
Okay, this one might be a little tricky. So if it's too mean, let me
Mhm.
know.
It probably will be too mean, but okay.
Okay, so let's do 2 times x plus y.
2 times x plus 1. Okay.
Yeah, so I threw in a second variable. How you
2
know I'm
times.
evil.
Okay. So parentheses, right? So like it's 2 times parentheses x plus y parentheses, right?
Okay, so we multiply the 2 times x, and then we also need to
Mhm,
multiply 2 times y.
mhm. Yeah.
So like this.
So what I was saying was okay. Yeah. Sorry.
Is that what you said?
Uh. Yeah. That's what I said.
Okay. Yeah.
Like.
Also,
Mhm.
oh, sorry.
No.
Continue.
It's sorry. Yeah. Uh huh.
Oh, I was gonna say, so you actually don't need that multiplication sign in the parentheses, because whenever
Oh.
a number or coefficient and a variable are touching, that lets us know they're being multiplied. So if you wanted, you could just write
Okay.
2x plus 2y, and that would be the exact same.
Okay.
Yeah, but what you wrote is good
Oh.
too.
Okay.
Yeah.
Yeah. I got it. Hmm.
Hmm. Okay, any questions about this?
No. I think I'm good.
You want to do another example, or do you think you got it?
I think I've got it.
Okay. Quick little screen grab. I know Zoom videos, but I don't know. Whenever I have class, I never actually go back and watch my Zoom videos. I would just read through my
Oh, you
notes
do?
instead. No, I have my Zoom classes are recorded, but I never rewatch the videos. I just go once
Oh.
and then forget about it.
Yeah. But yeah, got it. Okay. Okay.
Okay, so here we go. Oh, this one is kind of long. So the table shows the approximate median annual salaries associated with two levels of education, so bachelor's and a master's. So based on the data in the table, how much more money would a person with a master's degree earn than a person with a bachelor's degree over a 35-year career? Oh, you still there? Oh, okay. Your face disappeared for a bit, but now it's back.
Oh, okay. Okay. Okay, so basically you have to multiply both numbers times 35, right?
So you can do that, but there is an easier way.
Always an easy way out.
Yeah, the easy way out is all these numbers are really far apart, right?
Hmm.
So that you know what that means you can do? You can estimate
Oh, if you estimate, then it would probably be about $10,000 difference, right?
for
For
1 year.
yeah, for 1 year. So we have to multiply 10,000 times 35. So we multiply that, and I don't want to do the math, so it's 35,000, and 35,000 is close to A.
Mhm. Oh, sorry. I messed up my little
It's close
I.
to A. For me,
Yeah.
it is.
Yeah, it's close to A, right? Because
Yay!
35 and then we add in our zeros, that's what we get. Oh, sweet. Any questions about this?
Uh, uh,
Okay.
I
Yeah,
am a
so
god at this now.
good. Yeah, so whenever you see answer choices that are really far apart, it can
Hmm.
sometimes be a sign that you can just estimate.
Okay. Thank you.
You're welcome.
That could come very useful.
Yeah. If they're like close, like only like, I don't know, 10, 20 off, then you can't do it. But as long as they're close, you're good.
Uh-huh.
Oh, 10? Oh, we did tips a long, long time ago, like last semester.
Oh.
Oh, but this doesn't really have you calculate a tip. Okay.
Hmm.
They're nicer than I would have been.
That is true. A waiter earned a 17% tip. What decimal is equivalent to 17%? Mm, okay, yeah, that would be point 17, right?
Uh-huh. Yep, exactly.
That was surprisingly easy.
Mhm. Yep. If they were really
Hmm.
mean, they would have been calculate a
I
17%
like
tip
this
on a
change of
check of
uh,
$35 or
I
something.
like this change of difficulty around here.
That's good. I'm glad you like it.
Hmm.
Okay, let's try question 11. This is another
Okay.
percentage one.
Okay. Yesterday, 170 guests at a hotel called for room service. 250 realized. Ooh, God, this is gonna be hard. So we have the 70. First, we need to find the whole, right?
Yep.
So 425 is the whole, and 100%. We need to find the part. And that was so we need to multiply this and 425. So,
What number? You said your whole. What number are you using as your part? 170 or 255?
oh, can I show you?
Yeah, sure.
Okay, so here is what I did. Get my annotation, and I did. So I did 170 to
Hey, good.
425,
Perfect.
100%. This is unknown. Multiply, then divide.
Perfect setup. Great job.
Okay. Oh, there. Okay. Now I just need to solve it.
Mhm.
Mm.
This one there might be a bit of a shortcut.
Huh? Oh,
You know,
I'm
you know
I'm
I
almost
always
always done. Yeah.
Okay.
Mhm.
I'll tell you the shortcut once you finish.
Okay. 40.
Okay. Yep. Good job. So my shortcut
Yay.
here is
Mhm.
I know that half of 425 is 212.5, right?
Mhm. Mhm.
So 170 is less than that. So that means that our answer is going to be less than 50%. And so automatically I can eliminate A and D. And then 212 is pretty close to 170. So 15 is probably too small. And so you could
Oh
choose C
God.
by process of elimination. So that's another little test taking strategy you could do.
So much strategies.
Yeah, anything not to actually have to do math or the tricky
Yay.
portion at least.
Uh-huh.
Oh, here we go. We got another little. Oh,
Uh-huh.
this is prime factorization. Do you remember this? We talked about this a little too.
Prime factorization. It is. No, I don't remember. Can
Okay,
I
so
get?
I'll
Can
give
I get? Yeah. Can I
a
get a
little
quick
recap.
little? Yeah.
Okay, so do you know the difference between a prime and a composite number?
Yes. A prime. Well, I can't say every single word, but
You could give an example if you want.
yeah, a prime is a number that can't be. What is it? That doesn't have any multiples to it. I guess.
Or that we can't divide evenly, you know?
Oh. Yeah.
So like 2, 3, 5, 7, stuff like that.
Okay.
Composite, those are our other numbers,
Yeah.
so like 4, 6, 8, 9, stuff like that. Okay,
Okay.
so prime factorization is any number in the entire world, we can break it down into just prime numbers. So let's say we have the number 40. All we do is we make a factor
Mhm.
tree. So what are two numbers that multiply to 40?
Two numbers that multiply to 40 are 2 times 20.
Okay, so are any of these numbers prime?
No.
2?
Oh, yeah.
Okay. What about 20?
Oh yeah,
What?
sorry. I also forgot to mention another rule. 1 times itself does not count as one of them.
Yep, exactly. Okay. What about 20? So what factors does 20 have?
20 factor is 20 is 10 and 2. Wait, no, 2. Sorry. 20 is 5 times 4.
Uh-huh. Yeah, you can do any factors. You can do 5 times 4, you can do 2 times 10, either works. Okay, so we
Okay.
got 5 as another prime factor. So now we're at 4. So what multiplies to 4?
4 multiplies to 2 times 2.
Okay, good. So if we were to write the prime factorization of this number, we would write 2 to the third, and then this is important. So times 5. So we're multiplying. So 2 to the third is 8. 8 times 5 is 40. 40 equals 40. So we know we did something right.
Yes.
So what it wants you to do here is basically to get the prime factorization of these composite numbers.
Mhm. Okay. So then the answer would be F.
Okay, so 16 is 2 to the fourth. Yep, you got that one right. So we can eliminate J and G.
Mm-hmm.
So now we're on this one. So you said
And mhm.
F. Okay, let's look at 36. So
And
36,
then
3 and 12,
uh
3 and 4, 2 and 2, right? So this
yes.
is 2 squared times 3 squared. Okay.
Mm-hmm.
And then we also have a second 2 right there. So F is right because you got in that extra 2. Good job.
Yay.
Nice. I was going to tell you something about this. Oh,
Hmm?
yeah. Can't remember. Oh, this is adding. Okay, there's a trick that you can do if you're dividing, but we're not dividing, so I won't confuse you. But yes,
Okay.
good job. They have special exponent rules, but it's not really doing anything here.
Okay.
So,
Okay.
ooh, and inequality. Let's try 13. I think this might be our last one, or maybe 14 will be our last.
Okay. Which inequality represents all possible values of t. San Alexander, $600. She wants to spend part of her money on a computer. She wants to have at least. So. Oh, okay. So then this would be easy, right? So it would be 350, because that's the amount of money that you could spend.
Okay, so what you did is you subtracted 250 from each side, got
Yes.
350, and so you have it
Mhm.
like this. Okay,
Mhm.
so both A and C have 350. So which one do we want to choose, A or C?
We want to choose C.
C is right. And the reason why is we want to keep our sign the same direction. There's an exception to that. So if we multiply or divide, we flip the sign. So let me
Okay.
give you an example. So let's say we have, multiply or divide by a negative. That's important. So let's say we have negative 3x is, I don't know, greater than 30. So we need to divide by negative 3. So whenever we divide by a negative, we flip the sign. So x is now less than -10. And so we only flip the sign if we multiply or divide by a negative.
Okay.
Does that make sense?
Yes.
Okay. Any questions about this?
No.
Yeah. Okay. Let's see. Let's look at the next one. I don't want to leave off on inequalities. That's the worst. I don't like it. Oh. Okay, we don't have enough time to do the other one, but
Yeah.
I guess do you have any questions for me before I go about any of the stuff that we talked about?
No, I got it. Thank
You,
you.
you're welcome. You feel like the math is coming back to you?
No.
No,
And I don't want it to come back to me either.
it's okay. You'll be all right. I guess you have KDSD has school on Monday, right?
Yes.
Some of my sisters are in HISD and they have school I think canceled Monday and Tuesday. So that sucks.
Okay.
Yeah, but you got it, Peter. Enjoy the rest of your weekend, and I'll probably see you again soon for another class or something like that.
Okay.
Okay, bye. Have a good day.